right, so today we're going to kind of mix back and forth between writing quadratics in vertex form and standard form. And one of the things I want to talk to you about is how to find the y-intercept of the graph from either format. Okay, so y-intercept is where the graph crosses the y-axis. And if you guys will remember, if you have standard form, what you want to do in either case is plug in 0 for x, because if you're crossing the y-axis, the x value has to be 0. In the case of standard form, your ax squared plus bx plus c, it's always the point 0, c, because when you plug in 0, wipes out these first two terms, you get the point 0, the leftover will be the constant. Now, if you have vertex form, which we're going to practice in this first example here, you can't see the y-intercept from looking at the equation. What you want to do here is plug in 0 for x, and then you're going to solve, which is what we're going to do in the first example. Okay, so example 1 just says identify the y-intercept of the quadratic that's in vertex form. So remember, you can't see it here. Don't just write down the 3. You can see your vertex from vertex form. We would do our opposite copy. That would be your vertex. But to get the y-intercept, what you want to do, in any case, is plug in 0 for x, for any function. It doesn't have to be a quadratic. So for this problem, if I put in 0 for x, and I'm going to go ahead and simplify those parentheses there, that would just simplify down to being 5 squared plus 3. It's 25 plus 3, so 28. And then the actual y-intercept, what I would want to see right, I wouldn't want to see right y equals 28 because that's describing a horizontal line. You'd want to write down the point, so it's 0, 28, because we got that y value by plugging in 0 for x. This one just looks a little bit different because it has a number out in front of the parentheses. But again, if anytime I want to find a y-intercept, I'm going to plug in 0 for x. Now, most important thing I want to point out here, 0 minus 3, this is negative 3 squared here. When you're working, especially with this type of a setup, the biggest mistake people will accidentally make is they will multiply this negative 2 and negative 3 and then they will square it. Your order of operations has you do exponents before you do multiplication. So as I'm doing this, I actually need to square that negative 3 first in my order of operations. So negative 3 squared, negative 3 times negative 3, will turn that into a positive 9 plus 6. Then I'm going to go ahead and do this multiplication, negative 18, bring down that plus 6, and then go ahead and add those together. That'll give me a y-intercept of negative 12. So my answer here would be, again, I plugged in 0 for x, go ahead and write down negative 12 for the y value. Okay, now what we're going to work on in example 2 is I'm going to give you the vertex and I'm going to give you a point, and from that information that's plenty to figure out the equation of a quadratic in vertex form. Now the vertex form, I'm just going to write it like right here, y equals a times x minus h squared plus k. We've been working with this for a long time. So what's important to remember here, the vertex is your hk. And that's very important because we're going to plug this into the formula here. For the point, we are going to plug the point in for x and y. And then the only variable we won't know in this this vertex form is the a value. So I'm going to show you how to find that today. Okay, so it's y equals, so I'm going to put in the 9 from the point. I don't know the a value. The x-coordinate of the point they give us is 3. So those get plugged in because I know this relationship exists when that's the vertex of 5, 7. So if you look at the formula, it's minus the x-coordinate of the vertex, so it's going to be 3 minus 5 here, and then plus the y-coordinate of the vertex, which is 7. Now we are going to simplify this. This is a times negative 2 squared plus 7. Here's what I'm going to do. If you square negative 2, you're going to get 4. But what I'm going to do here, I'm going to write that in front of that a value. So this term here is going to turn into 4 times a, and then we're just going to solve this equation. I'm going to subtract 7 from both sides. This will give me 2. And then be careful, make sure you're getting a by itself. So I'm going to end up dividing by 4. My a value is then a half. So to actually write the equation like this up here in vertex form, you want the y and the x, and we're going to put 1/2 in place of the a, and then our minus 5 is going to stay the same, and our plus 7. We are just using the point to plug in for x and y while we solve for that a value out in front, because we know that relationship exists. So you use the point only in that process. You do have to have the vertex to have the vertex form. So I'm just going to practice that with you guys one more time. So it's very important you plug in the vertex for the h and the k, and then the point has to go in for the x and y. If you mix those up, you're not going to get the correct equation. All right, so again, the y coordinate, I'm looking at this formula right here, putting this in place of the y. A is the only thing in that formula I can't plug in something for initially. Use the x coordinate of the given point for x, and then your h and k go in for h and k. So h is -4. That would be minus a negative, so it's going to look like a +4 here. And then whatever the k value is, that just goes outside the parentheses, so I'm going to do a -8. Okay, go ahead, simplify the parentheses first. This will be 3 squared minus 8. So I have 3 squared is going to give me 9. I'm just going to write that in front of the a so it looks a little more typical. Add the 8. And we get 27 is equal to 9 times a. Divide by 9. And so my a value is 3, so I know everything I need to plug in to get vertex form. Y and x should be variables here. You want to have something plugged in place of a. That's why we were solving for that. X needs to be an x. And then it should say similar to the setup up here. It should just be +4 squared and then -8. All right, and then this is really a similar question. I'm just not voicing what the vertex is and the point. So you have to find the vertex from the graph. And forgive me, some of these copies, the grid lines aren't really easy to see. And the x and y axis here do both go by 2's. So I'm going to go ahead and write down the vertex, which is the point -2, 4. So that's my h and k. And I just label that so I make sure to plug that in correctly. And you guys can pick any point that you want to on the graph other than the vertex. You can't plug in the vertex again. So any point you can see here, I'm just going to go ahead and use the y-intercept there, which is the point 0, 8. And remember, any point that's not the vertex, you want to plug that in for the x and y. So again, here's your a times x minus h squared plus k. That's your vertex form. We got something to fill in for everything except a. So y, the y coordinate of the point. A, we're going to use the graph to help us figure this out by grabbing these points. X, I'm going to plug in the x coordinate of the point. This will be minus a -2, so it'll look like a +2. Y coordinate of the vertex is 4. This is a, 2 squared plus 4. If you square that 2, whoops, let me write it like I've been doing in the other problems. This will be 4a plus 4. I'm going to subtract the 4 here. So I get 4 equals 4a. And so that way, a is just going to be 1. Now, the pattern that we've been using to graph would not really work for this picture because the axes go by 2's. So you can't really look at the graph and use your 1, 3, 5 in here because we don't have each grid box marking a unit. So I want to do this algebraically just to make sure. But my equation here, they're not going to write a 1 in front of the parentheses. They're just going to start with parentheses. If it exists, it implies that there's a 1 there. So the a value is 1. That kind of would go there if we were thinking about it. This is going to be x plus 2 squared and then plus 4 for your equation. Now, let's slide up for this one. Some of these you might be able to figure out the a value, like I said, from the graph, but I would not recommend doing that if you have vertices that have an axis that isn't labeled where each unit is one spot because it's not as easy to see the pattern. I'm going to go ahead and do this algebraically. Your vertex is -3, 2. So that's my H and K. And then I just need any other point. I'm looking for something that goes right through a grid mark. You have a couple options here. You can see the y-intercept is 0, -1. If you wanted to, you could use this point over here, which looks like it's -6, -1. You just need some other point on the graph. I'm going to go ahead and use the y-intercept, but you can use any point on the graph that goes right through a corner. I'm going to use this for my x and y. So in place of y, I put the y-coordinate of the point. We don't know a, that's what we're using this to try to figure out. In for x goes the x-coordinate of the point minus the x-coordinate of the vertex. This is going to be minus a negative, so it's going to look like a +3. And then your k is 2. So -1 a times 3 squared plus 2. This is going to turn into 9a because I'm squaring that 3. Move the 2 to the other side. Divide both sides by 9 there. Now, you can see this graph is wide, so I know that my a value should be something between 0 and 1. It's negative because it's going to turn upside down here. This is going to reduce to give us an a value of -1/3. So to go ahead and write the equation, we're going to put that -1/3 in front of the parentheses. And then this will look similar, so it's going to be x plus 3 squared plus 2. And that's your equation in vertex form. And the last thing we're going to do here, I'm going to write out the example we just went through. I just rewrote the equation so you guys could see it on the screen, but you can see it on your paper. So I'm going to convert this equation into standard form. That's your ax squared plus bx plus c. So let's go ahead and go through and do that. So I'm just going to use part B because I don't have a ton of space. Now, remember, you cannot distribute this exponent. What you need to do anytime you have adding or subtracting is really think for yourself. Remember, squaring things means multiplying them by themselves. So this is going to cause me to have to FOIL this squared here. Now, it's up to you, but I would recommend go ahead and FOIL that set of parentheses first. Just going to leave this -1/3 out in front. Now, if you want to draw yourself a box to multiply that out, feel free. Just come over here, just do an x plus 3, do it that way. I'm just going to do a little FOIL right underneath here on my paper. So x times x is going to become x squared. X times 3 gives you 3x. 3 times x gives you another 3x. And then 3 times 3 gives you 9. Keep that plus 2, we got to use that eventually. Right here I can combine like terms. 3 plus 3 is 6, so we get 6x's plus 9 plus 2. And then I'm going to go through here and distribute this -1/3. So I'm just going to multiply each of these. This would be -1/3 x squared. Now, -1/3 times 6. If I multiply a fraction by a number, you do the numerator times the number, so -1 times 6. And then you're going to divide by the denominator. Or if you want to come over here do -1/3 times 6, you could do it that way too. But I just do numerator times the number, divide by the denominator. It's going to be the same action that you're going to get here. This is going to become a minus 2x. And then I can do the same thing with the 9. -1/3 times 9 over 1, or just -1 times 9 divided by 3. This is going to end up giving you just a -3, and then I'm going to bring down the plus 2, so -1/3 x squared minus 2x. Combine these guys, and you finish off with a -1. And maybe a quick way to check that, come right back up here. My y-intercept should be -1, and you guys can't see the graph, so I'm going to pull it down. My y-intercept is -1, so that would be a really good way as a quick spot check. But this is all multiplied out. Same equation, but in standard form.